All right, for those of you at home on quarantine or those of you who will happen to be at home reviewing, today is the 26th of October, and we today during class balanced chemical equations. This was our introduction to chemical equations and balancing of them. So we are going to take all of the things we've learned, coefficients, subscripts, analyzing a compound, analyzing elements, finding them on the periodic table, determining the number of atoms in a compound, determining the number of how you can change coefficients and how you can't change subscripts. All of that, right, culminates into this one particular skill that you need to develop known as balancing of chemical equations. So there are really truly four rules that you have to follow, or four sequencing of events that I want you to follow along. And I'm going to scoot these down out of the way just a little bit so I have a little bit of room. And the first particular rule, or I don't know what you want to call it, maybe process, let's say that, right, is to divide the reactants and the products. And that is a very, very simple thing to do. It is literally as simple as this. And realizing in your own head, right, that a product is the outcome of a mathematical equation. So in this case, based on the fact that we have this lovely little arrow here, this is going to be the product side. This is going to be the reactant side. So keep that in mind. We'll keep those labels there for future reference. But we do want to spend a little bit of time following along, right, and hopefully picking up some things along the way. This is going to be much like doing mathematics, pre-algebra, algebra. The more you do it, the more efficient you will be and the better you will be at it. So please bear with me and follow along with the many examples that will be posted either today or tomorrow. There are, as a second step, right, you must follow the general rule about chemical reactions, about subscripts, and about coefficients. You cannot change a subscript. You cannot change this subscript, nor can you change the subscript that is not even shown here. Okay? If a subscript from last week is not given, you know by now, at this point, it is always assumed to be a 1. Always. So I'm going to have you go ahead and put those in there just for mathematical purposes. And we are now going to move on to part B. You are only allowed to change coefficients. So where these little dashed lines are right here, you can add a 2, a 3, a 4, a 609. It doesn't matter what you add because you're adding more, right? You're not changing the molecular structure. You're only changing the amount that you're putting into a chemical equation. So cannot change a subscript, but can change a coefficient. Your third duty as you are balancing chemical equations is to analyze and evaluate the different elements that are contained in each chemical equation. So on the reactant side, Ag, as you now know because of the 25 common elements, stands for silver. And there are going to be 2 atoms of silver. Continuing on, the reactant side, there is a 1 as a subscript. So therefore, there is 1 atom currently. Going over to the product side, we have a subscript of 1. So therefore, we have 1 atom of silver on the product side. Excuse me. Oxygen on the product side, as the subscript tells us very clearly, it is a 2. So we have a little bit of an inversion here, 2 here, 1 here, 1 here, and 2 here. So we have to find a way to combat this. Right? I always like to start with the compounded side if you have what's called a breakdown. Okay? So you had a compound, it has now been broken down into its elemental form. I like to start here. I find it to be a little bit easier. So let's start with, we have a 1 and a 2. So we obviously have to multiply this 1 by at least a coefficient of 2 to achieve the same as a balance here and here. So let's work our way through this. And let's see what we can come up with. So the coefficient of 2 multiplied by the subscript of 2 for silver is going to give us 4. That same coefficient multiplied by this subscript on the oxygen of 1 is going to be 2. So obviously we need to make some changes on the product side. How do we achieve 4 silvers so that we have equality on both sides or equilibrium? How do we do that? Well, the easiest way would be to change the silver to a 4 because, again, multiplying this coefficient by that subscript is going to give you the 4 that you so desperately need to balance this equation. We need to come up with a 2 here, so we can ask ourselves what number times 2 is going to give us 2. Well, I'm hoping by now we all know elementary math, and that is a 2. So we have, ladies and gentlemen, followed every one of these rules except number 4. And the reason you're expected to follow number 4 is because this is very simple math, right? And once you learn the processes, there's no reasoning to get one of these wrong. So I'm really encouraging you to go back, double check, and even perhaps triple check your answers to make sure that you have them correct. And we will do exactly that right here, right now. So we have a coefficient of 2 multiplied by the subscript for a total of 4. Check. Okay. We have a coefficient of 2 multiplied by the subscript of 1. Check. 2. Done. Good. Looks great. That's the reactant side. Looks awesome. Let's move along to this particular side. We have this coefficient. We're going to multiply it by that subscript. Check. 4 times 1 is 4. We have a coefficient here, and we are multiplying that by this subscript. For a 1 times 2 gives us 2. Check. Great. We are doing well. It appears we have a balanced chemical equation. We've checked it. We've double checked it. And everything works out as it should. So that is number 1 in terms of how to balance chemical equations. Look for video 2 very soon.